हरिः कर्ता।
So now let's move on to the fourth step, which is pair plots under feature relationship analysis. So if you remember in our previous video, in that example, we wanted to explore the relationships between different variables under the data set. So what we did, we have taken two variables at a time and we have plotted the scatter plots. Just imagine, so we had around 20 variables, and for us, we are unable to create for each and every pair of variables. So that is the reason we have did it for three pairs of variables, and I left it to you so that you could explore. But is this really practical if you have plenty of variables and if you want to understand the relationship between two variables? Is it actually practical using just a scatter plot? Maybe not. That's the reason you got pair plots. So pair plots, also known as scatter plot matrices, remember the name. Pair plots, also known as scatter plot matrices, display scatter plots for all pairs of features in a dataset. They allow for a visual examination of the relationships between multiple features simultaneously. That's the power of pair plots. These are very, very useful. So it will reduce your 80% of efforts when understanding the relationship between various variables in your dataset or various features in your dataset. It reduce the 80% of your effort when you do feature relationship analysis. So they allow for a visual examination of the relationships between multiple features simultaneously. Pair plots are particularly useful when dealing with a moderate number of features, as they provide an overview of the interactions between variables. Of course, as the number of variables increases, it's pretty difficult to uh, understand and interpret the huge number of scatter plots in the one screen. In that case, you can split your features into 5 5 5, and you can plot a scatter plot matrices, or you can plot a pair plots. Okay, so now to explore how pair plots can be used to visualize the relationships between multiple features in a data set, we need to import a pair plot method from Seaborn. But this is the example. This is how you can basically visualize. You can plot a scatter plot matrices, or you can create a plot which can convey the relationships between various uh, features in one plot, and that is your pair plot or scatter plot matrices, and that you can see on the screen, and this is how it's useful. So the pair plot function from Seaborn automatically creates scatter plots for all pairs of features in the dataset. By default, it also includes diagonal plots for pairs of features in the dataset. By default, it also includes the diagonal plots which show the distribution of each feature. So the resulting pair plot will be displayed. So the pair plot will show a grid of scatter plots. You can see that you can see that on your screen. A pair plot is nothing but a grid of scatter plots where each cell, you see that each cell represents the relationship between two features. feature 1, feature 2. For this cell, feature 1 and feature 2. For this cell, this feature versus this feature. So the scatter plots on the diagonal show the distributions of each feature, while the off diagonal scatter plots show the relationships between different pairs of features. For example, if we look at the scatter plot between bill length underscore mm and bill length underscore mm, or bill length underscore mm and bill depth underscore mm, if you see the scatter plot between them, we can observe how the data points are distributed and whether there is a correlation between these two features or not. If you see this scatter plot, it clearly makes clusters: cluster 1, cluster 2, cluster 3. And here also you can see the clusters. Here not so, here not so, here not so. So this is clear cut clusters, this is clear cut cluster, this is clear cut cluster. Remaining we can find this is a clear cut relation, a positive correlation coefficient here, and the strength also would be pretty strong. Maybe it would be around 0.65, 0.7. It this one and this one as pretty positive correlation. So pair plots are useful for visually exploring the relationships between multiple features in a data set. So they allow us to identify patterns, clusters. You see that here you can find the patterns using the scatter plot or pair plots. You can identify either patterns or clusters and correlations between variables. So by examining the scatter plots, we can gain insights into the interactions between features and potentially discover interesting relationships or groupings in the data. Okay, so now let's take up a real-time data set and we will create a pair plot. It's a step 4. After the scatter plot, we'll go for the pair plots. Pair plots. Obviously, step 3 and step 4 can go together. You can simply say step 3 just a scatter plot, or you can say step 3 and step 4 which is scatter plot and then pair plot. So that's all up to you. Both go in hand with each other. Okay, so let's take an example now. Let's import Seaborn as SNS, and let's import matplotlib.pyplot as plt. So let's load the dataset. So obviously the dataset has been loaded. So let me print the data. So this is what is our dataset, and of course we have huge number of data points, and let me check how many columns we have. And this many columns we have: 1 2 3 4 5 6 7 8 9 10 11 12 13 14, total 14. So now it's time to create a pair plot. So let's create a pair plot for this data. Let's create a pair plot. So SNS dot pair plot of data. It's going to take some time because you have 14 variables and each a pair of variables should be plotted in a scatter plot. So that's the reason it's going to take some time. Let's wait patiently. Okay, it's ready. It's time to say plt.show. It's taking some time because here you can see it's saying the kernel is busy. So it's plotting the visualization is in making. So let's wait for it. Let's wait for it. The kernel is still busy, and you can see that asterisk mark here. So when you observe these two changes in your Jupyter notebook interface, you should understand that the processing has been taking place, and it's a huge data, basically 64,000 data points and 64,000 times 14. So it's huge. Fundamentally, the data is huge, and I'm trying to plot whole data in one shot. And here it is, a brilliant, a fantastic piece of plot. And here you can see, here this is your histograms, basically histogram of acidity, fixed acidity, histogram of volatile acidity. Okay, it by and large it looks citric acid looks normal distribution, and this is right skewed. This is right skewed, and this is also right skewed. This is closer, and this is normal distribution. By and large, this is closer to the normal distribution. It's absolutely normal distribution. You see that? You see that? And this one also normal distribution, and this seems uh, maybe slightly right skewed. Okay, and here you can see all the patterns of the data. And if we see, we cannot make out exactly what is the, it's huge amount of data has been clustered. I'm trying to find out the shapes. This is positively correlated, and this is certain extent positively correlated, and most this two, and this is positively correlated, and this one is negatively correlated. And let me check for the few more data patterns. And it's clear that it's evident that there are many data points which are outliers. Okay, and you can clearly make out the distributions here and here. Okay, so now let's do one thing. So as it is a huge number of variables, so that's the reason the visibility has become less. So now what we're going to do is we're going to reduce, we'll split the 14 variables into 7 7 or 6 6, because one is anyway a categorical variable. Let me do that, and let's plot it for that. So let's create a pair plot for just 6 variables. So this is data 1. I think so. So by the time you can just go through it. So different types of either you can find out the data distribution on the same plot, you can find out the pattern, or you can find out the correlation, whether it is positively correlation or negatively correlation, or not no relation at all. And here if you see, there is no relation. And here also randomly plotted, there is no relation specifically. And you can also figure it out, even the clusters. If you have a clusters here, all are very closely packed, we can't make the clusters. And most of the scatter plots doesn't have a proper clusters in this data. Okay, so data 1. Okay, we got the similar kind of let me go for data 2. Okay, it's still under making. Let me, yeah, this is, yep, it's better. It's better. Yep, it makes more sense for the visualization. And here it is. And it looks, you see that this one, it looks closer to the normal distribution. What is that? So citric acid data is normally distributed by nature. Fantastic, fantastic. And this is right skewed. This is right skewed. This data has been right skewed. What is that? Residual sugar. Okay, this is right skewed. And you can see that more plots on your screen. Mm, so I can't find any clusters properly. Other than that, you can figure out the outliers in every scatter plot. Okay, that's it. Let's take up remaining data points, remaining features. So total out of the 14 features, initially we have plotted all 14 features together here, then 6 features, then remaining features we are going to plot here. So that's how it helps in feature relationship analysis. That's how it reduced the effort that's put by a data scientist. And here if you see, and it makes more sense, it looks like a T distribution. You see that? Of course it's a normal distribution with the heavier legs, it seems. And this is again normal distribution, and this is right skewed. Fantastic, fantastic revelations from our data set. I'm very much excited. So when you do that exploratory data analysis and these kind of things, if you find, the excitement will reach the sky. So this is a different pattern, and here you can see negative correlation. It's falling down, it's negative, maybe the strength won't be that much. And here you can find out another negative correlation. Okay, you see that there is an increase and decreasing, and the fall is very high. The slightest increase is leading to a huge decrease. Okay, let me see that. Alcohol and density. Okay, this is alcohol versus density and more, and you can figure out, and that's what is a pair plot for you. So in addition to this, whatever we have did so far, we can also make it much more beautiful, and visually much more beautiful, and functionally much more useful. Okay, we can make it much more beautiful visually, and we can make it much more useful, much more useful functionally, by just adding one one and only one argument, which is hue. So let me add a hue here, and hue, and I have to provide a categorical variable. So let me say color, and let's execute. It's gonna take some time, and let's wait for that. And it's gonna add colors with respect to the categories. So this color has two categories, and let's see what all categories it has. We have seen in earlier case. Let me scroll it here. So color, yeah, color, it's a red and white, only two. Okay, now let's see. It's still busy, it's still busy. Let's wait for some time. So our plots will look much beautiful, and functionally it will be much useful. Because of that color plotting, it's easy to handle, and it's easy to basically understand the patterns. If we have any clusters, we can make out the clusters also with respect to that. So let's wait for the plot. So it's still busy. The kernel is still busy. Let's wait for some time, some more time. Okay, it's taking this much of time. That's okay. Yep, done. But it looks fantastic, right? You see that? You see this? Okay, you can literally see some normal distribution curves around. This is not, this is right skewed. This is multimodal. The bottom one is multimodal, and here you should see the normal distribution curves around, and you can see how beautiful it's looking, and it's easy to make out the overall. Okay, what's red color data and what is white color data set, and that's how the color makes a difference. And similarly, let me apply the same thing for this data set. So let me keep this same, and let me copy it down, and let me paste it. Hue, and again color. Even I can change the markers, of course. If I want to add a markers, I can add markers with respect to this uh, uh, for basically I have two categories, and one category I can put circle, other category I can make it a rectangle, but still that's possible. And here, see that, how beautiful it. And this one, the fantastic high peak, it has a high peak basically kurtosis, okay, platy and lepto. So this one with fantastic peakness, and this one with less peakness, and you can see the two normal distribution curves closer to that. And here you can see more, and the data set, and here you can see the patterns too, and certain amount of positive correlation, not exactly, not completely, but still you can see. And here you can see the negative correlation, and again negative correlation, and no correlation, no correlation, and no correlation. And that's how it makes beautiful. And here you can see that color red and white. That's what is pair plot for you.